It feels so good to be back. Hello everybody and welcome to this Unreal Engine 5 tutorial. However, today we're going to be doing something that could be used across programming as a whole and not just necessarily Unreal Engine 5. That's right, today we're going to be talking about modular. How can you make your programming a little bit more modular to make things easier not only for you but your designers and adding new features to your game. A quick caveat, this is not for advanced users. If you already program modular, this video is going to be very boring for you. However, at the same time, if you are brand new to game development, this video is going to be a bit advanced. I'm not telling you not to watch it, I'm just simply saying this is going to be a little bit difficult for you, and if it is, it's important to remember not to try to get imposter syndrome or feel like maybe you're just not cut out for game development. If this is difficult and you're new, you're right where you should be. Don't panic. Without further ado, let's get right to it. The first thing I want to do is take a look at how new programmers might tackle a light and switch system and some problems they may come across when they're not familiar with modular programming. All right, let's look at an example. On the left-hand side here, you'll see that we have a chair and a light. The chair is acting as my light switch, as I do not have a switch static mesh. And as you can see, it works just fine. However, the issues come whenever the area becomes too big. You'll see that now we have one point light and one chair, or switch in this case. So the only other thing we would be able to do is we could either duplicate the chair and then move the point light into position, but of course now we face the problem of, in order to turn these lights on and off, we have two separate switches. Another way we could go about solving this would be to duplicate this blueprint, call this like light 2, and then maybe in this instance we go ahead and we have 2 point lights, so we'll duplicate it. And now, since we have two, we could go over to the event graph, and instead of just setting the visibility of one point light, we could pull down the next point light, plug it in, and there we go. Now we have a blueprint for one light and a blueprint for two lights. However, again, we're still really limited. Let's say we have an area the size of this. What if an area the size of this? Eventually, we're gonna have so many different blueprints all running at the same time, just filling up our memory. So not only is it bad for performance, it's not a very good way for you to program in order to be efficient, effective, and save you time. While you may not have come across this problem specifically, I'm sure a new programmer has come across something like this before. Let's take a look and see exactly how the non-modular system is set up. This video isn't about interact systems, but just know that we have an interact request coming in, which is sending a message to the toggle light custom event that we have created in the event graph. It of course just checks to see if the light is on, and then it says, hey, turn off or turn on. Then turn off and turn on just sets the visibility of the point light to either on or off. Very basic setup that most of us learn and use for a while. However, let's say I'm the programmer at a new business and my job is not to design the game. It's simply to add the functionality. The designers come in and then they place the blueprints everywhere and start to develop and create these worlds. This is not going to work very well for them. They're going to have one point light, and as you saw in the examples, it's not going to go well. So let's actually exit Unreal Engine and go to the whiteboard. I don't know where my markers went. God. So let's take a look and see what's happening, but on the whiteboard. So as you can see, we have our interact request coming in, which by the way is already modular. You'll know why by the end of the video. It checks to see if the light is on, and then it either turns the point light on or off. But notice that it specifically says point light. Do you remember algebra? Do you remember thinking, there's no reason I'm ever gonna use this? Well, welcome to thinking modular. No longer are you going to do this, okay? Technically, the on boolean could be modular, but it would be overkill because it's a light. It does two things, so a boolean makes sense. Instead, what we're gonna start doing is interact request. Is it on? Well, X. Now I'm aware some of you just went into full panic mode, math, oh god, but don't worry. Even though it's technically math, it's gonna be super simplified because of blueprints. So right now, as you can see, point light is very specifically defined. In the top left, we have a component, point light, very specific, unbreakable. We need that to be modular. We need it to be something that can be free form, so no matter how many lights we have, one switch can contain them all. But at the same time, it also can't just be point lights. A lot of detail lighting and things like that come from rect lights, point lights, spotlights, and this is where things start to get very difficult when you're new. But let's do this very slowly. So let's start with the first problem. The first problem is simply we have one point light. What if we want more? And more specifically, what if we want more but to maintain a single blueprint? We know this isn't going to work, so let's go ahead and delete both of these custom events, which also means we need to delete them off the toggle. We'll come back to this in a few. Go ahead and compile that. And in fact, we're going to take it one step further, and we're actually going to go ahead and delete the point light out of our component list, because no longer are we going to program multiple elements into one blueprint. It makes sense sometimes, but I chose a light switch system because it doesn't make sense here. I'm going to go ahead and delete this light 2 that I duplicated earlier, as well as I'm no longer going to call this BP light 1. Instead, I'm going to call this BP light switch 1. That's correct. This will forever now just be a light switch. It's no longer both. We're going to teach you how to separate these because it's part of becoming more modular. So now we have a switch, but we don't have a light. Or do we? Let's go back to our first person example really quick. If I go up here, for example, and I go to quickly add, we go to lights and we pull out a point light. This is actually how you're going to see most designers, and yourself more than likely, go about designing their levels. It's much quicker. You're not worried about blueprints that are attached to them. You can just go up there, it's a quickly add for a reason, and just start designing and start building. Of course, as a programmer, especially one that's new to modular, you're in a bit of a panic. We start adding in all these lights. Yes, it's gonna yell at me because these are not optimized at all. It's gonna be like, oh, overlapping. They're overlapping. It's fine, don't worry about it. But they're gonna have all these lights and you're like, how are we gonna get all this attached? Let's head back to our switch. Do you remember what X's are actually called in algebra? Or most letters, for example, X, Y, Z? They're called variables. And as a programmer, you've probably heard of variables before. In fact, on the left-hand side, as you can see, we have an entire tab known as variables. What if we were to add a variable and we just called this point light? Then I hit this drop-down menu and I type in point light. You'll notice that there is something here called point light. And I can actually make it an object reference. Just for clarity's sake, an object is the highest level, quote unquote, blueprint that you can have. Just note that an object, when it comes to programming, is a set of information that travels together. That's the simplest way that I can put it. So imagine a blueprint with way less features. So whenever we're getting a point light object reference, the only thing we need that object to be is some sort of point light. So therefore, it is a very high level reference. The reason I'm throwing this at you, even though you're new, is because it's important to understand the difference between a high level reference and a low level reference. The more low level it is, the more specific. The harder it is for that variable to accept something because it's looking for more details. Whereas the higher level something is, the less details it needs. Think about an object reference as saying, hey, I need a vehicle. Whereas a really specific reference would be like, I need a 2007 Sebring with a dent in the side and a flat tire. You'll note that all of a sudden you need something very specific. So when you're programming modularly, yes, there are times you'll use low-level specific references, but most of the time, you're actually looking for that high-level, very less specific reference. So we have a point light object reference. Now, in case you didn't know this was a thing, this little eyeball here that says variable is not public and will not be editable, on an instance of this blueprint. Let's define instance, because when you start getting into modular, you need to know what that means as well. An instance is purely saying this specific context, like this exact one. Like for example, if you had two blueprints and they were both toothpick holders, this one is slightly different than this one. Ultimately, these could be the exact same blueprint, but because this one has just a little bit of a difference, it's a different instance than this one. So by making this public, we're saying this variable can change in an instance to instance basis. Some of you that are more adept are already knowing what the next step is going to be, but I'm going to skip it intentionally and show you why we do the next step. Let's go ahead and click on one of our, remember these are just switches at this point. Let's click on one of our light switches. You'll notice, by the way, if you go over here to the right hand side, there's a new default panel, and look, there's something called point lights. That's the variable we created. And the reason that it's showing up right here is because we opened up this eyeball and said, hey, I want this variable to be changeable from instance to instance. So now that it's here, notice we have this eyedropper tool. We can actually click the eyedropper tool and add this point light. So now we have the switch, and in this case, X, or this variable, equals this specific point light. To save us both time, instead of showing you the problem, let me briefly explain it. I could add the code right now to where now this switch will turn this light on and off. But we've already seen that, and we know that it's still a problem, and as you can see, I can only have one point light in this variable. So instead, before we add all that code and waste everyone's time, what if we could make it so that variable could be anything from 0 to infinite? We do that with something called an array. An array is a fancy word for a list. So we create a list of point lights that we want that switch to toggle instead of that one point light. The way we do this is there's a couple ways, but my favorite way and the easiest way, in my opinion, is next to point light over here. You see this dot? That blue dot indicates an object, by the way. However, if we right click that dot, now it's an array. See how it's 9 dots instead of 1? Arrays can be more than 9, but it's a way of showing you that it's multiple. So let's go ahead and compile that, save, and let's take a look at our new default variable on the right hand side. You'll see that we have point lights, where there are currently 0 array elements, okay? Well, as you can see, I placed 4 lights earlier as the designer. So if I click 1, 2, 3, 4, you'll note that we now have 4 array elements. I'll eyedropper tool the first one. I'll eyedropper tool the second, third, and fourth. Meaning this switch, this specific instance, now controls all 4 of these lights. Just to show you that each instance is different, if I click on this one, notice this one has 0 array elements, but this one on the left-hand side still has all 4. So let's go ahead and program how this works. We need to recreate the turning on of the lights and the turning off of the lights. We could do this without a function. However, whenever you start learning about modular, it's very important to start using functions. So we're going to go over to the left-hand side here, and we're actually going to create a new function, and I'm going to call this turn lights on. What do we want turn lights on to do? Well, we need it to turn all the point lights in the array on. We don't care how many there are. We just know that there's an array that might have 0 and it might have 100 lights. It doesn't matter. We need all of those to turn on. So I'm actually going to drag point lights onto the event graph and I'm going to hit get. And you'll notice that now we have this little array icon on our point lights. We're going to teach you something called a for each loop. Now, it's important to know whenever you're new to programming that for each loops can be infinite, which will crash your computer, it'll crash Unreal Engine, it's not good. Luckily nowadays, things like Unreal Engine and your computer have a lot of buffer, a lot of safety protocols to stop an infinite for each loop. However, I'm going to show you how to make sure it has an escape in case something goes wrong. Out of the point lights, we're going to pull out and we're going to type in for each. And you'll notice there's a for each loop. For each does exactly what it sounds like. It looks at the array and says, for each. So in this case, for each point light, we're gonna do a thing. The loop body arrow is what it's going to do every time it goes to the next element in the array, the next item on the list, the next point light. The array element is the next thing on the list. So for example, on this loop, we want to set the visibility. So set visibility of the light component to on. However, this is where we need to start thinking about potentially causing an infinite loop. Remember that when you program something, your code is very dumb. Why is it dumb? Because people like us are the ones telling it what to do. It's not doing anything that we do not tell it to do, which means that if we tell it to infinitely loop through this array and something has caused the array to be empty or maybe have infinite spaces that are all empty, it's going to run forever. We never told it to stop. So a simple way to do this is to run an isValid check. Down here we have this isValid and it's a question mark. Essentially all it's doing is it's saying, is this real? Like, is it actually there? And only if it is valid do we want to set the visibility and continue. If it's not valid, we want to do something called return. In programming, whenever a for each loop or a function returns, it will stop every single time. So in this case, if we get to a light component that's not actually there, we need to return, stop, quit, hit the brakes, emergency, stop, something went wrong. Now, luckily, it should almost never hit that return node. It's more of a safety protocol. While you may never use the emergency brakes in your car, I'm sure you're happy it has them. So let's briefly go over what just happened. For every single point light, I want you to check and make sure you have a real light component, and, which you should, go ahead and set it to true. And that's it. Now we could get the array index, which is simply the address of the point light in the array. And sometimes people will even add return nodes here as well. Now technically the for each loop completed, so you don't need a return node, but it's good practice. And now I'll hit compile. Oh, the error is very simple. It's the set visibility doesn't have a target, which of course we want that to be the light component. Now I'll hit compile. And there we go. We're going to create another function, and this will be to turn lights off. Luckily, a lot of this code is exactly the same. So I'm going to go ahead and just grab all of it. I'm going to hit copy. We're going to go to turn lights off, and we're going to hit paste. To be honest with you, anytime you copy and paste code like that, it should be a huge red flag up here that you're reusing a lot of elements, which means you might not need to do it. But I'm going to try to keep things simple. Essentially, for those that want to know, I'm not going to teach it, but for those that want to know, instead of copying, pasting, turn lights on and off as two different functions, just make toggle lights the function instead of just turning the lights on and off. Don't worry about what I just said if you can't follow. Anyway, so yeah, we're turning the lights off. So we're going to do the exact same thing, but instead of new visibility being true, we're going to set the new visibility to being false. We're going to hit compile and save. Now, in this case, all these lights are turned on. And we know they're turned on just because that's the default way that they are. I'm gonna move these closer to the ground so we can like super see them. There we go. Now we could set up logic to check and see if the light is on or off and then go from there. However, to keep things simple for now, we're gonna go ahead and go to our on boolean, make sure the default value is true. So that way the light switch already knows that the first step is off, not on. In fact, I just thought of something. We do need something out of this complete. Well, when it completes, what do we need to do? Well, we need to update the variable. If we turn the lights off, we need to make sure the variable is set to being off. And same goes for on. If we turn them on, we need to make sure that the variable is set to being on. Now, we're gonna do a pop quiz. Why am I not putting this here? Oh, not that. Why am I not putting this here instead? Well, because we don't need to set this to on for every single light that is coming out of the array. The lights are turning on. We don't need the variable in this one blueprint to turn on every single time. We only need it to happen once, which is why out of the complete, so once it's done, then go ahead, run your on boolean and then return. With our functions created, let's go back to the event graph. So we have our toggle light. If the light is on, so on is true, well, we need to run the function, turn lights off. If on is false, lights aren't on, well, we need to turn lights on. Remember, the thing that's calling toggle light is I have an interact request. The interact request comes in, it toggles lights. It's very, very simple. Now, let's go ahead and double check our switch. Remember, we have 4 array elements. If you hit this little arrow, it'll show them. It's the 4-point lights we created. Let's go ahead and hit play. I'm gonna go and hit this. You'll see this one turned off, but notice all 4 of these turned off as well. And if I hit the button again, now all 4 have turned back on. I really hope this video helped you learn how to think a bit more modular. Very basic example, and there's a lot more things to learn. If you want me to go further with teaching modular, let me know in the comments below. If something's confusing or I missed something, also let me know in the comments below. Thank you so much for watching. I really appreciate it, and I'll see you guys in the next video.